Okay, so for today's lesson, we're going to talk about lateral and surface area prisms. So a prism is also can be considered to be called a polyhedron, and that's just a solid that's enclosed by polygons that are on different planes. The bases of the polyhedron are the bounding polygons. The edges are the intersections of those faces. The vertices are the intersection of the edges. You can have a diagonal that goes through the solid. And the diagonal goes through the solid, it's a straight line that joins any two vertices that are not in the same face. So basically what you're looking at is this diagram where you've got 6 different faces, right? Those are the 6 different rectangular polygons. You also have those vertices that are the corners, and they're showing you the vertices, A, B, C. They don't actually have all of them, but A and B. So again, it's really quickly. Here's like the front, one of the faces of the 6. Here happens to be a vertice. The edges happen to be the things that connect one plane to the next, et cetera, et cetera. So the other piece of it that we're talking about is the diagonal. And the diagonal would basically be a line that if I were to go from this top corner of A down to this bottom corner of B, I would actually connect a line that goes through that particular prism from top corner to bottom corner. Okay. If we talk about a prism specifically, a prism is a polyhedron that has 2 parallel faces. The 2 parallel faces, which are called the bases, happen to be the congruent polygons, and the other faces we call lateral faces. So if you take a look at what we have right now, we have got a pentagonal prism. And the reason why it's a pentagonal prism, I spelled that wrong. There we go. That's better. So we've got a pentagonal prism because these 2 bottom bases are the shapes of pentagons. Now remember, it's very hard to show a 3-dimensional object on a 2-dimensional piece of paper. All of the lateral faces around it, other faces, I think I did not complete that, happen to be parallelograms. So if we look at all the sides that connect pentagon to pentagon, these lateral faces all happen to be parallelograms. The height of the prism is the length of any perpendicular segment. So the height of the prism is the length of any perpendicular segment that's drawn from a point on one base to the point containing the other base, to a point containing the other base. I think that's a typo. So we're looking for the height of the prism. I'm just going to go smack down in the center of that top pentagon, and I'm going to go down to the center, what should be the center of the bottom pentagon, and I'm going to draw a right angle, and that would be considered your height. Okay. A right prism is a prism whose lateral edges are always going to be perpendicular to the bases. All lateral faces of a right prism, like we said before, are always rectangles. Okay, so we've got the height, which is going to be down here. Sometimes they call the height the altitude, by the way. I think that probably will get brought up as well. Let's keep on going. So the following formulas are used to find the lateral area and the total surface area of the prism. We'll talk about lateral area. Lateral area, depending on what bases you're talking about, and sometimes you can talk about different bases, especially if you're in a rectangular prism, might change. So I do believe they give you these formulas on their Regents exam, on the formula sheet. So we'll talk about the way they do it, and we might talk about it a different way as well. But lateral area of a prism is the sum of the areas of the lateral faces. Or what they say is if I were to talk about lateral area, it would be perimeter times height. In other words, if you find the perimeter of the base and you multiply it by the height of the solid, that's what's going to give you the lateral area. And we'll show you that in a second so it makes more sense. The surface area of the prism is going to be the sum of the lateral area and the area of the bases. So surface area is going to be whatever the lateral area is, plus the area of each base. That's why it's 2b, where b is the area of the base. So if we're going to find the lateral area first, then we're dealing with lateral area being the perimeter times the height of the solid. Well, the perimeter of the base of this particular triangular prism, we've got to add up all the sides, and we're missing the hypotenuse. We know that there's a right angle here, so if we know your triples, it's going to be a 3, 4, 5. So the perimeter of the actual triangular base, 3 plus 4 plus 5, which happens to be 12. The height of the solid is what goes from base to base, and that's going to be 10. So your lateral area is 12 times 10, or 120 units squared. If we now talk about the surface area, we need to do the lateral area plus twice the area of the base. Well, we already know what the lateral area is, so that's perfect. The triangles, if we think about the triangles, the actual base part, the base we know is a triangle, which is base times height divided by 2. But don't forget, we've got to multiply that by 2 because we've got two particular bases. So we're going to plug in the base and the height, which is 3 by 4 divided by 2. That's the area of one triangle. We're going to double that because that's the area of two triangles. What's going to come out here is that the base of the two triangles ends up becoming 12 divided by 2, which is 6, times 2, which is 12. So surface area equals the lateral area plus the area of the two bases. Sorry, that should be surface area. And that ends up being 132 units squared. The one thing that I wanted to show you about lateral area, because sometimes the formula is sort of hard to follow, or maybe you're just would rather do it a different way. Another way to do the lateral area is to find the area of all the three rectangular faces and then add those up. And that's another way to do it. So if you think about this one particular bottom rectangle, this hopefully you see is a 10 by 4 rectangle. So I could take rectangle 1, which is 10 by 4 or 40. I could take rectangle 2, which would be this side rectangle, this 5 by 10. So rectangle 2, which is 5 by 10, which is 50. And then all the way on this back rectangle, that's 3 by 10. This is rectangle 3. It's 3 by 10. That's 30. And when you add up all of those, 50 plus 40 plus 30, you still get 120 units squared. So you need to decide whether you'd rather go by the formula pH or you want to actually find the areas of each particular rectangle and add them up. Okay, next one. Find the lateral area and the surface area of the right rectangular prism. So you need to decide which one happened to be the bases of this prism. Hopefully you see that there's 4 rectangles that look all congruent and 2 rectangles that are not. I'm sorry, well, that are congruent to each other but not congruent to the other 4. These two particular sides, like I'd say left and right side, those are the ones that I'd consider to be your bases, especially if you're dealing with the lateral area equals perimeter times the height. So what you're going to do is you're going to say, okay, well, the perimeter of one of those bases happens to be 5 plus 5 plus 6 plus 6, and that in fact gives you 22. The height of the solid, which is going to be this guy right here from 11, and then if you're dealing with lateral area, 22, by the way, you've got calculators for sure for all of this. 22 times 11, your lateral area comes out to be 242 units squared. If we go for surface area next, remember surface area is lateral area plus the area of the two bases. The two bases we know, I'll just kind of start this up here, 242. The two bases, so the base is the shape of a square, and we need two of those. The square is going to be a 5 by 6, but we have to double that, which means it's 30 times 2 or 60. The two bases total an area of 60. So the entire surface area here is 302 units squared. Okay, so we've got one more example to go. The last example. If the base of a prism is an equilateral triangle with sides of 3 centimeters and each lateral edge measures 5 centimeters, what's the lateral area of the prism? What's the total / surface area of the prism? So maybe we need to draw this. So if we draw this thing out, not going to be perfect, but I'll draw a triangle here. I'm going to draw a triangle here, and I'm going to connect top. I'm going to connect bottom. I'm going to connect bottom. So what's happening here is we know that the sides happen to be 3. And we know that the lateral edge from triangle to triangle is 5. So lateral area, we know is the perimeter times the height. Well, the perimeter of the triangle, that's pretty easy. The perimeter of an equilateral triangle is going to be 3 plus 3 plus 3, which equals 9. It's the height of the triangle that we have to be careful about. And, oh, sorry, the height of the solid, my fault. So the height of the solid happens to be 5. This is the easier one of the two. Sorry about that. So then the lateral area equals the perimeter times the height, or 45 units squared. If we deal with, and I'm going to drop this down, if we deal with surface area equals the lateral area plus the area of the bases. It's here where we have to be careful. So if we're dealing with this particular triangle, this equilateral triangle, we need to find the height of this particular triangle because that's how we find the area of that particular base. Well, if the whole bottom side is 3 and we drop down an altitude, then each little piece of this thing is going to be 1.5. Now remember, it's equilateral to begin with. So that means all of the angle measures started out as 60. We've got the height giving us a 90. Therefore, we've got a 30, 60, 90 triangle. So now you have to go back to some old stuff. If you take a look at this 30, 60, 90, what ends up happening is if your short leg is 1.5, your height is 1.5 radical 3. So then when we calculate the area of the two bases, don't forget that the two bases are triangles. So we've got the two triangles, which is base times height divided by 2. We're going to double that, which means we basically have the base of the triangle is 3. The height of the triangle is 1.5 radical 3. We're going to divide that by 2, and then we're going to double it. Essentially what happens is these twos would cancel each other out. So then the area of the two triangles ends up being 4.5 radical 3. So now we can do our surface area because the surface area is just the lateral area plus the area of the two bases. Lateral area we know is 45. The area of the two triangles, 4.5 radical 3. They're not like terms. Here's where we stop it, and it becomes 45 plus 4.5 radical 3 units squared. Okay, so that's it. So you should be good for the homework.